What do you understand by sharpness of resonance for a series LCR resonance circuit? How it is related with the quality factor Q of the circuit using the graph given in the diagram. Explain the factors which affect it, for which graph is the resistance R minimum. Okay. Now, the sharpness of the resonance is when resistance is low in series LCR circuit, large current flow at the angular frequency is close to the resonant frequency, such as LCR circuit is said to be more selective. That means we know that V is equal to I times R and I is equal to V by R. That means I is inversely proportional to the resistance. Okay, that means when the resistance is decreases, when R is decreases, automatically the current will be increases. Right? From the graph, the current amplitude versus we can see here the current, that is the current amplitude versus omega we can see here. Okay, and where L and C is fixed, that means here R1 is greater than R2 and is greater than R3. Right. Now, let us suppose that the value of omega is such that the current in the circuit is 1 by root 2 times the current amplitude of resonance. Then omega 1, then we have omega 1 is equal to omega naught plus delta omega. This is in the upper segment, and when omega 2 is equal to omega naught minus delta omega. This is the lower segment. Then we can write it as omega 1 minus omega 2 is equal to 2 times of delta omega. Right. This is called the bandwidth of the circuit. So delta omega divided by 2 delta omega measure the sharpness of resonance. Mathematically, we can write it as E is equal to E divided by under root of R square plus XL minus XC whole square is equal to 1 by root 2 times I at omega naught. Then we can write it as E divided by under root of R square plus XL minus XC whole square is equal to 1 by root 2 times E by R, where E will get cancelled. Then we'll get under root of R square plus XL minus XC whole square is equal to root 2 times R. Then square on both sides, we will get R square plus XL minus XC whole square is equal to 2R square. Then we'll get XL minus XC whole square is equal to R square. Then we'll get cancelled, square will get cancelled. Then we'll get XL minus XC is equal to R. Then where XL is equal to omega L, XC is equal to 1 by omega C, then we can write omega L minus 1 by omega C is equal to R. Then we can write it as this one, omega naught plus delta omega times L is equal to 1 by omega naught plus delta omega times C is equal to R. Then omega naught L times 1 plus delta omega divided by omega naught minus 1 by omega naught C times 1 plus delta omega divided by omega naught. Then omega naught times L into 1 plus delta omega divided by omega naught minus omega naught L divided by 1 plus delta omega divided by omega naught is equal to the R, where XL is equal to XC because of XL is equal to XC, because XL is equal to XC. Okay, then we can write omega naught L into 1 plus delta omega divided by omega naught minus omega naught L into 1 plus delta omega divided by omega naught to the power of minus 1 is equal to R. Then omega naught L into 1 plus delta omega divided by omega naught minus omega naught L into 1 minus delta omega divided by omega naught is equal to R. Then we'll get omega naught L into 2 delta omega divided by omega naught is equal to R, where omega naught will get cancelled. Then we'll get delta omega is equal to R by 2L. Then, therefore, the sharpness of resonance is equal to omega naught divided by 2 delta omega naught is equal to omega naught L divided by R. Then the ratio of omega naught L divided by R is called as the quality factor of the circuit, and it is denoted by the symbol Q. Then we can write Q is equal to omega naught L divided by R. We can write it as Q is equal to 1 by R under root of L divided by C. This is the quality factor Q of the circuit. A 2 microfarad capacitor, 100 ohms resistor and 8 Henry inductor are connected in series with an AC source. Find the frequency of the AC source for which the current drawn in the circuit is maximum. If the peak value of EMF of the source is 200 volts, calculate the first one, maximum current and inductive and capacitive reactance of the circuit at resonance. Okay. we'll see we know that is the part B, and right here B. Okay, we know that V is equal to 1 upon 2 times pi into under root of LC. Okay, then if you are going to substitute the values, 1 upon 2 times of pi value as it is 3.14 also you can substitute, no problem, and the root of L is equal to, they are given it is L value is equal to 8 into C is equal to 2 into 10 to the power of minus 5. Okay, then we get when you simplify you will get the value that is 1000 divided by 8 into pi value, then we get the answer 39.81, or we will get 40 hertz. Approximate is 40 hertz. Okay. Now we know that here the given V0 is equal to 200 volts. Then we know that I0 is equal to V0 divided by Z, that is equal to V0 divided by R, because Z is equal to R at resonance. Then we can substitute the values. It is 200 divided by 100, which is equal to 2 amperes. Okay, at resonance XL is equal to XC. At resonant XL is equal to XC, then XL is equal to omega L, which is equal to 2 pi V into L. If you are going to substitute the values, that is 2 pi, V is 39.81, 39.81 into L is equal to 8, then we get the answer is 2000 ohms. Draw a schematic diagram of an AC generator, explain its working and obtain the expression for the instantaneous value of the EMF in terms of magnetic field B, number of turns N of the coil of area rotating with an angular frequency omega. Shows how an alternating EMF is generated by a loop of wire rotating in a magnetic field. Okay, first we will see the schematic diagram of AC generator. It looks like this. That means in between the two magnetic poles, that is north and south poles, a coil is placed. Okay, now with a coaxial, two slip rings are also there, and it is connected with the carbon bushes, and an alternate EMF is also there here. Okay, let's see the working principle here. Whenever coil is placed in uniform magnetic field and is rotated, a flux linked with it changes, and an EMF induces in the coil. The end of the coil are connected to an external circuit by means of slip rings and carbon brushes. So the flux linked with the coil of area A placed in uniform magnetic field B. Okay, then automatically it is connected to the an external device for storage. Then it will store the electrical energy, or if you are going to connect here any electronics devices, it will be work according to the power generated. Okay, now coming to the second part here, we need to find the expression for the instantaneous value of the EMF in terms of the magnetic field B. Okay, that we know that here 5b is equal to BA cos theta and B5b is equal to BA cos of omega into t, because theta is equal to omega times t. Okay, considering this as equation number 1. Then from the Faraday's law, EMF induced in the coil, that is epsilon, is equal to minus n times d phi b divided by dt, that means phi b with the dt. Then we will get nba minus nb times a d by d theta into cos of omega t, and epsilon is equal to nba omega sine of omega t, or epsilon is equal to epsilon naught sine omega t, where epsilon naught is equal to NBA omega. So yes,